And we're back. Uh, right. I I forgot that the stream was actually taking up um taking up some memory. When I ran this earlier, I had just booted my machine, nothing was running, and it managed to complete. Uh, but yeah, it was about half a minute left when I aborted it. Basically, it's just allocating heaps and heaps and heaps of memory. I compiled it with was this no? I have since closed that terminal. It seems. Um, yeah, I have closed that terminal, so we can't have a look at it. The problem here is that it's allocating so much memory in this massive sequence. I did manage with the release switch to bring it down from 2.5 minutes to about 25 seconds just by switching the release switch. The reason for that, the release switch just does away with some checks that helps with debugging, which you don't need when you're compiling release code that you have sort of tested. So in this case, you would be testing on the sample input. Then you would turn on release mode and run your actual code. And as with anything, if you're trying to compare speed, like this guy is, he's saying, why isn't this as fast as my twin basic code? So he's trying to measure speed, but he's doing debug builds, which are gonna be just inherently much slower. And he seems to now, after I started this stream, he compiles with derelease, danger, verbosity. So danger overrides release. Verbosity and hints off. Those are just compile time switches, so they wouldn't change his output. And this gives 24 seconds versus 480. So it's way faster. I'm not going to try to run this because it will probably allocate just as much memory and crash my stream again. But that is the main reason for his slowdown. Now, you might ask, but Nim is a fast language. So even if the code is slow, if his twin basic code is doing the same thing as the Nim code, why is Nim slower than the twin basic version? Nim is supposed to be fast. I mean, it's way faster when you turn on the actual release switch. So it is faster than twin basic, but why do we get so bad numbers? And part of the reason for this, and it's a thing that you sort of encounter when you're talking about Nim and comparing Nim to other languages and that kind of thing. Nim's data structures. So when you're writing languages, you all like programming languages, you always have to ask yourself, what are people going to use this language for? So what? Oh, I have switched cameras since last time I streamed. So what are people going to use my programming language for? And you want to optimize for that use case. And Nim's use case is sort of kind of like the better C group of languages. We try to do something faster. We try to do something that like compiled, statically typed, all of those things. The trade-off that is made to get that is that the data structures, like the default data structures that are chosen, are fast if you use them right. If you're using the right data structures for the right things, they're fast. If you but you can use them in a wrong way and you get really detrimental performance. So the string is a good example. If you have a string and you split it up, you create a bunch of more strings. A faster data structure would be to keep a reference to the original string and just keep like sub ranges in the string, and then copy on write or something like that. The reason why nim doesn't do this is because that if you just want small strings, and if you're using them right, then you're actually paying an abstraction fee incurred or put there by people who want to use the data structures in a different way. So nim has packages for stuff like strings that you can do these kinds of things with, which are faster. But the default string data structure and the default sequence data structure are not intended to be used in that way, so they're not optimized for those use cases. Now, if you're writing a programming language like, I think this Twin Basic is based on Visual Basic, and I think Visual Basic was always meant to be a sort of beginnery kind of language. I'm not sure if it's a language. This might just be my ignorance, but if you're writing a language that is intended to be used by people who don't necessarily know computer science or know data structures or know sort of how to do these kinds of things, and you're just optimizing for something else. You're optimizing for decent performance in a lot of cases, instead of great performance if you use it right, and then sort of a detrimental performance case if you're using it wrong. So it's all about like, how is this optimized? What is it optimized for? And in these kind of naive benchmarks, nim can be slower than languages like Python, languages like Ruby, like scripting languages. It could be slower than even stuff like Bash or like, in this case, Twin Basic. And much of that is just because the naive solution is not the solution that is optimized to work with the language the way you're supposed to use it. So that is my sort of long-winded solution, or my long-winded explanation on why is this code slow, even though it is faster if you just switch on the release switch and get speed. But that's a different issue. So yeah, it's a bit, I mean, I hate saying this, but it's a bit like the whole like you're holding it wrong thing. You're not playing to the strength of the language. And I mean, there's nothing wrong with using a language without other trade-offs. Like I have written this like stack-based calculator, which also has a lot of, like, you can make commands, you can like it is an interpreted language, which does, like, it's based around doing math, but you can write your own functions if you have stuff that you run often, and you can do like labeling, like labels and conditionals and all of that good stuff. And it's horribly slow because it's not horribly slow. It has okay performance. It's not super fast, but the thing about this language is that it's made for doing math in my terminal. I write something, I do the math. I might define some simple functions. Like I might say, I have this formula for the size of a sphere. I don't want to have to like type out the pi and 2 and time by the power of that and this and that. So I code that into a function, and now I can call that function. And that is the kind of thing that I use it for. And for that, it's great. It's a terrific little language. And it uses map'em numbers under the hood, which is the math library from C that I wrapped in one of my articles. So it has like arbitrary precision. So this is sort of more correct than a float. I think, what if we do, just for fun here, these numbers might not be big enough for this to be an issue. 100 divided by, oops, let's make sure these are floats, divided by this. Right, so I get the E minus 1, 4302, 4923, 4466, 495. It's actually pretty good. 495, and then it rounds this 5 here up to a 6 for some reason. So, bad example. Floats were actually just fine for that. But it has arbitrary precision, just because I wanted arbitrary precision. I just wanted to be able to do all of this math and have it just be nice and precise, and don't get into these weird cases where you get 0.00000000000001, or cases where you get 0.9999999 something because of floating point rounding errors. I just didn't want that. So I wrote my own thing. It's not fast. It's not meant to be fast. It's optimized for something completely different. And it's fast enough for what I intended it for. And that's the same for languages. You need to optimize your language for the use case that you need. And if you use it for something it's not intended to do, you might get detrimental performance. I'm guessing Twin Basic might do string slicing a bit differently, which means that if you need to push for performance, you might have a harder time optimizing, getting the speed as fast as you need it or want it. And just as a sort of example, 24 seconds or 480 seconds. This is part 2, day 4. I think my day 4 was pretty okay. So let's just run no release flag. That runs in 12 milliseconds. With release turned on, it runs in 2 milliseconds. Yeah. And that's probably mostly this, like, starting the program. So there you go, from 24 seconds to 2 milliseconds, which is 5 orders of magnitude, 4 orders of magnitude faster, just by doing it in a more efficient way, in a way that is more optimized. Data structures are more optimized. It's more the way you're intended to to do it. So that was my little lecture for today. Hold your toys the right way up, and they will be much more fun. Drink from the right side of the glass. But yeah, that's it for me. These VODs will probably get all kinds of messed up. So yeah, good luck if you're looking through the YouTube stream. And by the way, oh yeah, I lost all the YouTube comments when it crashed. See you tomorrow. Yeah, I will probably be doing one of these tomorrow as well. It's Thursday. Yeah, that should be doable. I have to do some repairs on my car, but apart from that, I should be done in time for 8 o'clock, which is when I try to start these. So yeah. See you tomorrow. Then it's only gonna be one day, back to the normal schedule. Yeah, my solutions, as always, will be available on GitHub. I will upload 5 and 6 after this. Also a link to the list, like the playlist of recordings. So you can see me solving all the days in there. And yeah, that's pretty much it. Good night, I guess. It's half past 10 or quarter to 11 here, so I'm probably going straight to bed. Yeah, goodbye.